Welcome to lesson 9-5, which is on parametric equations. This will be a quickie, I promise. We're going to start by just talking about what parametric equations are. Parametric equations are still linear equations, or not necessarily linear, but plane equations, y and x. But y and x are both defined in terms of a third variable, which we often call t. Okay, which is often time, and it's called a parameter. The graph of a parametric equation is called a plane curve. When you're graphing on the graphic calculator a parametric equation, we will do a lot of this in class. You're going to change your mode from function to parametric. Most important thing, or one of the things we're going to do, and we'll do it in this video, is what we call converting a parametric equation to just a regular equation in y and x form. This is called eliminating the parameter. Your steps are basically solving one of the equations for t, plug it into the other equation, and solve for y to get a function. If you're dealing with trig functions, which we will do some of too, then you're going to deal with the Pythagorean identities. Let's just graph actually one parametric equation real quick here, and I did a little work to save some time. But if we look at x equals 3 minus 2t, y equals 2 plus 3t. This is a parametric equation where x and y are both defined in terms of t. T is my parameter. I'm just going to let t be 0, 1, 2, 3, 4. When I do that, notice x becomes 3 and y is 2 when t is 0. When t is 1, x is 1, y is 5. When t is 2, x is -1, etc. Same thing with when t is 3 and 4. I'm going to plot those points. So I have the ordered pair 3, 2 about here. I have the ordered pair 1, 5 about here. I have the ordered pair -1, 8 about here. I have the ordered pair -3, 11 about here. I have the ordered pair -5, 14 way up here. And I can see, sure enough, I have a linear equation that is written, was written as a parametric equation. I can figure out what that equation was now by eliminating my parameter. And I'm going to do that by solving for t. I think I will solve the first equation for t. I'm going to do that by moving the 2t to the other side and subtracting x. Did I go too fast? I'm going to divide both sides by 2. So t is equal to 3/2 minus 1/2 x. I'm now going to take that t and plug it into my other equation. So y equals 2 plus 3 times t. Well, t was 3/2 minus 1/2 x. So this then becomes y equals 2 plus 9/2 minus 3/2 x. Well, 4.5 plus 2 is 6.5. So y equals -3/2 x plus 6.5. And, on my rough sketch, we can look back at my original graph. Does that make sense? Sure. Not bad. Let's do another one. This time, x is already solved for t, or t is already solved for x. So quite simply now, we are going to plug in y equals, well, t is equal to x, so I'm going to replace this t right here with x. So y equals x to the third. This is quite simply just a third degree polynomial function. Let's try another one. Let's solve the first equation. X equals root t for t. I'm going to do that by just letting t equal x squared. I squared both sides. Now I'm going to take this x squared and take this t, which is x squared, and plug it into here. So y is equal to 1 minus x squared. Now, be careful here. So, generally speaking, this is a parabola, which would look something like this. But in this particular case, we notice that t cannot be a negative number, nor can x. X cannot be neg, so therefore we're going to get rid of the half of the graph where x is neg, and this quite simply is going to be a parabola, but just on the positive side. Okay, now looking at our last example, we have a trigonometric parametric equation. I'm going to start by saying, okay, I'm going to let x equal cosine theta, and again, we're thinking of theta as our parameter. I'm also now going to solve this for sine theta, and do we agree I can divide both of these by 3? So y over 3 is equal to sine theta. Now I'm going to think about something that I know. I know that cosine squared plus sine squared is equal to 1, the Pythagorean identity. Well, I'm going to replace cosine with x. So this is going to be x squared plus sine squared. Well, sine is y over 3. So sine squared is going to be y squared over 9 is equal to 1. This is looking awfully elliptical to me. If I think of x squared as x squared over 1, I have the equation of an ellipse, and there we go.